Okay, so we're going to talk about optimization, which is useful, probably things that you learn, because optimization is one of the things that they use a lot in businesses, in even like in finance and things like this, where they want to always optimize. Okay, and with optimization, as we talked about before, is you want to either minimize or maximize. That's what the word optimum means. Right? It's your minimum or maximum that gives you the best thing that you can come out with, okay? And we talked about on Friday, you guys did the inquiry, right? Of if I have a set perimeter, right? What rectangular shape gives me the best area, right? And then we also did if I have a set area, what best shape gives me the best perimeter, right? So we're going to talk about this today, but we're going to talk about 3D shapes, okay? So it's not going to be 2D shapes, it's going to be 3D shapes. So the purpose of optimization is to, if you are a business person, okay, and then you're trying to produce something, okay, and you want to produce a box, okay, do you want to use too much material or do you want to use too little material to make your object? The least amount, right? So you want to minimize the surface area, right? So the purpose of optimization is to minimize, because you want to reduce your costs, right? So minimize the surface area and you want to maximize the volume. Now, I mean, yes, we can do this, we can find the best answer, but sometimes it doesn't work, right? Sometimes it doesn't make sense to use that specific shape to make my box or to make whatever, because I'm trying to optimize, okay? We'll see some examples that it doesn't make sense, but we have to solve it because the question is asking us to, okay? So when we are dealing with rectangular prism, the optimal dimensions will always be that of a cube, because we found that the square shapes gives me the minimum perimeter and the maximum surface area. And that's the same thing when it comes to 3D shape. Square becomes a cube as a 3D shape, right? So that of a cube. Now, since the length, width, and height of a cube are all the same, we refer to all the sides as the letter S. Sure, you can call it whatever you want, okay? In this case, we're going to refer to it as the letter S. So if you're looking for the surface area, if you look in your formula sheet, the formula sheet of it doesn't give you the formula sheet of a cube. It gives you the one of a rectangular prism, yes? So let's look at a cube. To the best of my ability. Okay? And then you have side, side, side. Okay? So if you're looking at a cube, how do you find the surface area of a cube? What is it? So the surface area. So surface area is adding all the sides. Yes, the area of all the sides. What's the area of this side? Side times side, right? Length times width, because my length and width are the same, so it's S times S, which is S squared, right? I have 6 of them, right? So that means my surface area is 6S squared, right? Now, for the volume of a cube, volume is length times width times height, right? Which is, it's going to be S cube, right? So these are the formulas that we will be using to optimize rectangular prism, or to optimize when it comes to a rectangular prism. Okay? We're not going to use the one in your formula sheet. It's always, how do you know that you're optimizing? It's going to say calculate the optimal, okay? Or calculate the maximum, or calculate the minimum, okay? So here's a question. The volume of a shoebox is 5,000 centimeter cube. Calculate the optimal dimension of the prism. So, what am I looking for? What? Dimension. So I'm looking for the side length, right? What is given to me? The volume. So what formula do I start with? Exactly, right? Because the volume is given to me, then I have to start with the volume formula. So volume equals S cubed. My volume is 5,000. To find the side length, what do? You're going to have to cube root, right? You have to cube root to get rid of that cube. Okay? So to get rid of that cube, you cube root, and then you'll be left with S. What's the cube root of 5,000? Did we get that? 7. Okay? So that tells me that each one of my sides, for it to become a cube, to give me the optimal dimension, is 17.1 centimeter, right? So to answer the question, I don't stop right here. I have to say that the optimal dimension of the prism R, and then you're going to state it as 17.1 centimeter by 17.1 centimeter by 17.1 centimeter. So what are you optimizing here? No, you're optimizing the surface area, right? You're optimizing, you're finding the dimensions that gives you the optimal surface area, okay? Because your volume is constant. Your volume is not gonna change, right? It's given to you, so you're optimizing the surface area. If I'm gonna add to this question, I'm gonna ask you, what is your optimum surface area? What would you do? So I'm going to add to this question. I'm going to say part B, what is your optimum surface area? What would you say? How would you find your optimum surface area?
Side by side, 17.1 squared.
Remember the surface area is 6 times that, right? So you're going to have to use the formula surface area equals to 6s squared. So that's going to be 6 times 17.1 squared, and the answer is going to be And the answer is going to be 4,678.56 centimeter squared. Make sense? So you do 16 times 17.1 squared times. Oh, sorry, 6. That's my mistake. I did 17 for some reason on the calculator. Okay, so that is a wrong answer, and it should be 1,754. Are we okay with this? Okay. So the surface area of a pizza box is 45,000 centimeters squared. That's a mistake right here. So that should be centimeters squared. Find the dimensions of the optimal pizza box. So what shape should it be? A cube. Does it make sense that I form a cube pizza box? No, it doesn't make sense. But the question is asking for the optimal. We're going to have to find the optimal. Okay? It doesn't make sense. And as I said, we're going to have to answer the question even though it doesn't make sense, but we're answering it. Okay? So they gave me the surface area of a pizza box, and they're asking me for the dimension for the optimal pizza box. Okay? One. And then I'm started with the surface area of 45,000. So what do I do? Yeah, so what formula do I start with? So SA equals 6S squared. My surface area is 45,000. And then I'm solving for S. What do I do?
So first area will be divided by 6.
Yeah, so first divide by 6. And that's going to give you 7,500. And then? And then that is going to give you, when you square root both sides, that's going to give you 86.6 centimeter. Okay, so the dimension of the optimal pizza box where the dimensions are. Again, I can add to this and I can ask you what are you trying to optimize here? So you found these dimensions to optimize what? You're going to optimize volume, right? If they give you the surface area, then you're optimizing the other one, okay? So I can ask you, I can add to this question, what would be your optimum volume? Right? Then you just have to do V equals S cube and that is 649,461. That's huge.